In this problem, I'll be using the real number line to simplify expressions involving negative symbols and absolute values. So for example, starting with this problem, inside the parentheses we're starting with the number -4. The number -4 by definition is the number 4 units to the left of 0 on the real number line. You can think of it as this is moving 1, 2, 3, 4 units to the left of 0. So that describes this number, but what we need is, because of this symbol, the opposite of -4. So if -4 is 4 units to the left of 0 on the real number line, the opposite of that would be defined to be 4 units to the right of 4 on the real number line. And you may think of this as that you could draw a reflection line at 0 and that we're reflecting this going from 0 to -4 so that it goes 4 units to the right. So it would be 1, 2, 3, 4 units to the right of 0 rather than 4 units to the left. So the opposite of -4 comes out to be +4. To show you a slightly more complicated example, let's start with the number -3 and then do two opposites of that. So -3 would be 1, 2, 3 units left of 0. So we would be here at -3. And then the next stage would be to take care of this negative symbol here, which means that we need the opposite of -3. -3 means 3 units to the left of 0. The opposite of that would be 3 units to the right of 0. So you could think of this line here in the middle being a reflection line, and you can reflect that over here. And that would look like this, so that you'd be looking 3 units to the right of 0. So the opposite of -3, this entire thing came out to be +3, but there was more to the problem. If all of this that I've circled in green comes out to be +3, don't forget we still have this symbol, meaning we still want the opposite of that. So we are sitting over here at +3, and now we need the opposite of that, and the opposite of 3 units to the right of 0 would be 3 units to the left of 0, taking us back to -3. So the opposite of +3 is -3. So this may be a bit confusing that we swapped back and forth, but if you wanted to summarize, here is the problem that we were given, and we started with -3. The opposite of that would be +3, and then the opposite of that would be -3. So our final answer came out to be a -3. Let's do some examples that involve the absolute value. Here we have the absolute value of -2. The absolute value symbols represent the concept of distance from 0. So the number inside -2 means that we are 2 units to the left of 0, so we are right here at -2. But the absolute values say that we want the distance that that number is from 0, and distance is always thought of as positive. So the distance from this number to that number is 1, 2 units. So the answer is that the absolute value of -2 is +2. Now to do a very similar example, suppose I didn't have just the absolute value of -2. Suppose we had a problem where we wanted the opposite of the absolute value of -2. So if you let me use the result from this here, we just said that the absolute value of -2 represented the distance that -2 was from 0, and that piece of it came out to be +2. And now what we want is that we want the opposite of. So copying this symbol down here, this came out to be +2, and now we want the opposite of that. And the opposite of 2 could be described in the following way. 2 is 2 units from 0, so we'd be here, but we want the opposite of 2. And the opposite of moving 2 units to the right of 0 would be moving 2 units to the left of 0. Again, you could think of that as moving this across the reflection line, which instead of putting you 2 units to the right of 0, would put you 2 units to the left of 0. That leaves us with a final answer of -2. Sometimes in these longer computation, a summary helps. We started with the absolute value of negative 2. Here's negative 2. The absolute value is the distance that negative 2 is from 0, and it is 2 units from 0. Since we always think of distance as positive, that piece came out to be 2. But then we still had this symbol here suggesting we wanted the opposite of 2. The number 2 is 2 units to the right of 0, but we needed the opposite of 2, which would be 2 units to the left of 0, finally putting us at the answer negative 2 at the end. I'd like to do 2 more examples that are very similar looking. We started with a simple example that looked like this, and I'll erase this in a second. Compare that with this problem, which looks almost identical. But if you see them side by side, notice that this problem had a negative on the inside of the absolute values, whereas this problem has a negative on the outside, and this completely changes the answer. So this problem having the negative on the outside has a completely different meaning than if it were on the inside. So as always, I will start with this piece here, temporarily ignoring the opposite symbol here. The absolute value of 2 could be described as follows. The 2 inside the absolute values, you could think of as the number 2 as being 2 units to the right of 0, so we're here. The absolute value symbols, by definition, are the distance that number is from 0. The number 2 is 2 units from 0, so that piece comes out to be the number 2. And if the absolute value of 2 is 2, we're done with that part of the problem, but don't forget that there's a negative symbol here that means that we want the opposite of 2. The opposite of 2 could be thought of as, since 2 is positive, that means we're 2 units to the right of 0. The opposite of that would be defined to be 2 units to the left of 0. So you could think of it as you're reflecting about this reflection line, or just that instead of moving 2 units to the right of the 0, you're moving 2 units to the left of 0. And if you did so, you'd be at negative 2. So to summarize, the absolute value of 2 is 2. But in the end, we wanted the opposite of positive 2, and the opposite of positive 2 came out to be negative 2, and that is our final answer. Let's just do one more. And this problem is very similar to the last one. In fact, this piece right here is exactly the last problem we did, so let me summarize how that went. The number in the innermost piece of the problem is the number 2. We argued that that would mean that you're 2 units to the right of 0 since it's positive. The absolute value of 2 is defined to be the distance that number is from 0, and 2 is 2 units away from 0, so that piece came out to be the number 2. So that part of the problem came out to be positive 2, but we still have that negative symbol, a set of parentheses, and yet another negative symbol. Then we could argue, as before, that since 2 is 2 units to the right of 0 and we want the opposite of that, the opposite of 2 units to the right of 0 would be 2 units to the left of 0. So that would put us at negative 2. So this whole piece here, the opposite of positive 2 comes out to be negative 2. But don't forget, you'd still have the set of parentheses and another negative symbol. So here we are sitting at negative 2, that was here, and now we want the opposite of that. So if negative 2 is 2 units to the left of 0 and we want the opposite of that, that puts us back 2 units to the right of 0, which puts us at a final answer of 2. Again, sometimes in these problems, a summary of what happened helps because there were so many steps to the problem. This piece of the problem said the absolute value of 2. What is the distance between the number 2 and 0? That came out to be the number 2. So then we said we don't need the absolute values anymore, but we still had several parentheses and some negatives here. This said that the opposite of positive 2 is negative 2, so that piece became negative 2, but that only described this piece, leaving this negative symbol out here. So then we had to say that the opposite of negative 2 was positive 2, and that was our final answer. Because you likely are doing this problem in Math AS, you may want to see how it would play out in this environment. So for example, question A has you performing the opposite of the absolute value of negative 6. So not to give you the answer, but to show you how the problem works, if you think the answer to question A is 6, you'll be dragging question A into this area. Had you thought that the answer to question A is -6, you would drag question A into this area. It turns out that there are several questions, in fact A through H, so you will be dragging each question letter into either the box that says that you think the answer is 6, or the box that suggests you think the answer is -6, and you would do that for all of the questions A through H, and then when you're finished, don't forget to hit the submit button to receive credit for the parts that you did correctly.